and welcome to math class. I just wanted to tell y'all to go ahead and get to this page in your math journals. It is simplifying expressions. It should be right after page 88 or the stuff that we did in class yesterday. So simplifying expressions in your math journals. I'm going to give you another 20 seconds to get there. You can also anticipate needing this page as well. It's going to be the next page over in your math journals. So make sure that you go ahead and pull that page out too if you're someone that likes to pull out pages in your notes. I just wanted to go ahead and restate the expectations before. I know some of these classes have had subs and some of y'all haven't, but I expect any substitute teacher to be treated better than you treat me. And you guys already treat me super, super well. So I expect the sub to be treated super, 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 super well. I know that every single one of y'all is capable. The rules that are there when you are in my classroom are the same rules that are there when the substitute teacher is in your classroom as well. So that means that when this video is playing, y'all's volume is at a level 0, which means no talking at all. In addition to that, when you guys do your independent practice later, your volume is a level 1, which should not be higher than whispers. All trash should be picked up off the floor. All pencils should be returned. And whenever I am writing on this screen, you are also writing in your math journals. We are doing something new today. This is our new unit. We are in Unit 2. The day before the test, we will go back over the PFL unit that we were just in to make sure that you guys are prepared for that. So we're going to go ahead and start on simplifying expressions. And just to prepare yourself, today there are numbers and letters and math. But do not let your brain explode. Do not let your brain freak out. Because as long as you understand that it's okay to have letters, Miss Dunn is going to teach you a very easy way to deal with both letters and variables in math without making your brain go poof, okay? Miss Dunn's favorite type of math is math that has letters and variables. It can get very, very fun. It's like solving a puzzle. You just have to get over that initial of having letters and numbers in math. Okay, so an expression is a mathematical phrase that can contain variables. And I'll zoom in so that y'all can see this. That can contain variables. Now, variables are your letters. Variables are your letters. Okay? So a mathematical phrase can contain variables, numbers, we're very familiar with those, and operations, which include addition, subtraction, multiplication, and division. Now, an expression does not have an equal sign. If it has an equal sign, it is called an equation. An expression does not have an equal sign. It might look something like this. Or like this. Okay? All it is some numbers, maybe some letters without an equal sign. We see it all the time. Now, the word simplifying means making all of your letters and numbers combined as much as you possibly can. So this simplified would be 8. This right here is already simplified, and we'll talk about that in just a second. All right, so a term is a number or a variable, or, and I know there's not one right here, a number attached to a variable. So let me just write down an example of this. Oh, wait, I'm sorry. It says separated by addition or subtraction signs. This is also a negative. addition or subtraction signs. And an example of this that we could set up would be something like this. 3x plus 5. This right here is a term. This right here is a term. This entire thing is also called a term. But when we talk about combining like terms, which we'll talk about in just a second, we're not talking about the whole thing. We're just talking about each of the individual terms. Once again, you could have and this is a term, and this is a term. Or you could have all of these individual things right here are terms. Now, I'm sure that you see that I've written the letter X several times. When you see simplifying expressions and you see an X, it no longer means multiplication. This X right now is a variable. So if you see an X next to a plus sign, it is not multiplication next to addition. It is just an X, the letter X. It is a variable. All right, a coefficient is the number in front of a variable. It's the number in front of a variable or a letter. So this right here is a coefficient. This right here is a coefficient. This right here is a coefficient. And this right here is a coefficient. It's just the number in front of a variable or a letter. Now, like terms must have the same base. What that means is that they must have the same variable, which means they got to have the same letter. And they have to have the same exponent. And another word for exponent is power. But just to remind you of what an exponent looks like, the little thing floating up in the sky is called an exponent. So what this means, if you look at this expression right here, the reason why I wrote them in different colors is because this is not a like term with this. It's because this has a letter and this does not even have a letter. This right here is not. This right here is not a like term with this right here. They have the same letter, but they don't have the same exponent up in the sky. What that means is that we can't do any operations with these. They are as simplified as they can get. Now that we've talked about kind of the obscure side of this, let's go ahead and label some of the parts of our expression below. So if we take a look at this D right here, I hope you're writing in pencil because I want you to take about 5 seconds and think about what this is based off of the definitions up there. This D right here is a letter and therefore it is a variable. It's pointing to the 4. Now if you're looking at the 4, a technical term for this would be that it is a coefficient because it is attached on to our variable. So we have our variable and then we have our coefficient. Now the entire thing of 4D is called a term. The number 9 right here is just a number. It's also considered a term. This subtraction sign right here is subtraction. And one of the more formal names for that is an operation. Now, this entire thing right here, which is what this box down here at the bottom is indicating, is a term, but we're just going to label it as an expression. I'll give you guys a second to get all of that written. It says use the definitions above to give you, to help you complete the following. It says give an example of an expression with 3 terms. So there's a couple ways that we could do that. We could say 3x plus 9 plus 3x squared. This can't be combined with this because they don't have the same letter. Oops, sorry. This can't be combined with this because they don't have the same exponent. And this can't be combined with this because they don't have the same letter and they don't have the same exponent. Another example could be 3x plus 4y plus 8z. You won't see this very commonly in 7th grade math. You might not see it at all after this. But the reason why these aren't like terms is because they don't have the same letter. None of them have the same letter. So those are a couple of examples. This one says list all of the terms in the expression below. So go ahead and take a second and circle all of your individual terms. Okay, you should have gotten that this was a term. And notice how I included that negative sign in there with it, because that subtraction sign is also technically a negative sign. So we do want to say -5 when we look at this term right here. This is a positive 4c squared, and this is a positive 2b. Those are all terms. This one says to circle the coefficients in the expressions below. The coefficients are the letters that are attached on, take that back. Throw whatever I just said out the window. They are the numbers attached to the letters. The numbers attached to the letters. They are the numbers attached onto the variables. That is what a coefficient is. So go ahead and take a second to circle those. And you should have found this right here. Now this one says, give an example of a like term for each of the following. For it to be a like term, it has to have the same number, it has to have the same letter, and it has to have the same exponent. So, for -50 right here, we just have to write down another number. I'm going to write down 2. You can write down whatever number you want. It just cannot have a letter. When we look at 3b, it has to have the same letter attached onto it. So, an example of that could be -7b. You can write down whatever you want as long as you have a b, and that b does not have an exponent. When we look at c right here, -5a is c, you know what I mean. Okay, when we look at this right here, it has to have the same letter, and that letter cannot have an exponent. So I want you guys to try to come up with one on your own. Okay, you maybe got something like 100a. If it has the same letter and it doesn't have an exponent, you got it right. For this one right here, it has to have the same letter and it has to have the same exponent. You can go ahead and put a number in front of this if you want to. My example is going to be 3x squared. Okay. We're going to skip past this. And we're going to skip past this right here. So, when I come down here, I am going to highlight what are called like terms. That means that they have the same variable and they have the same exponent. So, there's a couple ways that you can identify like terms. If you like to use highlighters, you can go ahead and get those out now. If you don't like to use highlighters, I'm going to use highlighters, and I'm going to go with this other method of underlining the numbers, just in case you don't have a highlighter. So I'm going to start with my highlighter, and I'm going to make it purple. Now, our like term that goes with 7a is going to have the same variable, and that's going to be 8a. -6 doesn't have a variable whatsoever, so it's just -6. Now, I like to rearrange to where my like terms are next to each other. So I'm going to have 7a plus 8a minus 6. Now, when we add things with variables, we just add together their coefficients. So 7 plus 8 is 15. And then don't forget to write down your a. And then you have -6. Now for this whole thing, if you didn't have a highlighter, I forgot to explain this, I can use my pencil to identify like terms like this. I'm going to underline 7a once. I'm going to underline -6 twice, not the same terms. And I'm going to underline 8a once. So if it's underlined once, then it's a like term. If it's underlined twice, then it's a like term with the other one. So for this one right here, we cannot combine this and this. They don't have the same letter. If they don't have the same letter, you can't combine them. So our final answer is 15a minus 6. Let's take a look at this one right here. I'm going to highlight, and then I'll show the underline. I have -3d. I know for something to be like term, it also needs a d. So we have 8d right here and -5d right here. All of those have d's, so we can add all of them up together. Now, I'm going to go one by one. Oops, sorry. I'm going to underline these since they're all like terms. -3d plus 8d. They are different signs, so we subtract their coefficients. 8 minus 3 is 5. Then our 8 is bigger than our -3. So we're going to keep this a positive, and then don't forget to write down your d. Then you have 5d minus 5d. They are different signs because remember, this right here is a -5d. They're different signs. 5d minus 5d, you're going to do 5 minus 5 and get 0d. Now, this is technically 0 times d. So our final answer is just 0. I forgot to explain this a little bit further. This is technically -3 times d. This is technically 8 times d. This is technically -5 times d. Let's take a look at this one right here. We have that's not negative. We have 1.5g. So we're going to look for our other thing that has a g. That's this right there. Those are like terms. Then we're going to look at our other numbers that are highlighted. We have -10. -10 doesn't have a g, so it's not a like term. Then we've got this number right here, -3. It goes along with -10. They both don't have letters. Remember, if you are writing and you don't have any highlighters, this and this are like terms, so they get underlined once. This and this are like terms, so I'm going to underline them 2 times. 1.5 plus 1.5g plus 6.5g. I'm going to put them right next to each other. And then we have -10 and -3. So now we're going to add together. I forgot the g on this. Whoopsies. Remember, when you add together your like terms, you just add together their coefficients. So we're going to add together 1.5 and 6.5. And when we do that, we get 8.0. So I know that this is 8.0 G. Now, we're done with that over there. So I'm going to have -10 and -3. -10 and -3 are the same sign. So I'm going to add together the numbers and keep the signs. These right here are both negative numbers. So I'm going to add them together and keep the sign. My final answer is going to be 8G minus 13 because I cannot combine this and this. They are not like terms, so I cannot add them together. I was able to just drop the 0 because 8 and 0 cents is the same thing as $8. Let's take a look at this one right here. We're going to highlight our like terms. So we have 1.5 H. So I'm going to look for my other things with H's. We have a 2H right here. And then we have a 3/2H right here. And then we have a -1. For those of you that do not have highlighters, I'm going to underline my H's one time. I'm going to underline my -1 twice because it's a different term. These are not like terms. All right, so we're going to add together 1.5 H and 2H. So if I added 1.5, if I add 1/2 plus 2, that'll just give me 2.5. So I have 2.5 H plus 3/2 H minus, -1. Now, this right here is a normal fraction. It's a mixed number. This right here is an improper. So if you remember, we have to turn this into an improper fraction. So I'm going to do 2 times 2, which is 4. 4 plus 1 is 5. So I have 5.5 H plus 3.5 H minus 1. Now, we're going to add 5.5 over 2 and 3.5 over 2. And 5.5 over 2 plus 3.5 over 2 is 8 over 2 H minus 1. Now, we're going to simplify our 8 over 2. So we're going to have 4, because 8 divided by 2 is 4, H minus 1. And that's our final answer. The reason why this one was more complicated than the last one was because this time you have fractions. It's not because the letters are hard. It's because the fractions can be challenging. But the letters themselves are easier to understand. It's just like with this one, we just added this and this. We added our 7A and our 8A, and then we didn't do anything with our -6. Combining like terms is not hard, but fractions can be. All right, I want you to go to the back of this page. This page right here, you are going to turn in to the back a minute before the bell rings. You're going to turn this into the back before the bell rings. You're going to turn it into your period bin. If you finish before the bell, you can play on a Chromebook, you can do a connect the dots, you can nap, whatever your substitute is okay with. You are not allowed to get up out of your seat. You are not allowed to distract the students around you, and you are not allowed to get on your phones. Same expectations as we always have in the classroom. Now, you don't have to do this one. And you don't have to do this one. These right here are challenge questions. Those right there are challenge questions. I did want to take a second and do number 7 with you. So, because it's a lot of negative numbers down here. So we're going to combine like terms. So I'm going to highlight my like terms. I need anything that has a P. This right here has an R. It is not a like term. So I'm going to write negative 4P minus or negative 15P minus 2R. Now, both of these numbers right here are negative. So, when we have two negatives, we add together the numbers, and then we keep the sign. So this is going to be negative 19, and then don't forget your P, minus 2R. And we cannot combine P and R, so this is our final answer. Okay, once you are done, turn this into the bin in the back. Even if you do not finish, turn it into the bin in the back. I want to see how much you are able to do. You are able to work with the person sitting next to you, but your volume level is expected to be a volume level 1, which is whispering. Okay, good luck, y'all. Have a great rest of your day. Thanks for being an amazing class.